Hello everyone. Now in the previous video I spoke about shells, and in particular the CLI, the command line interface. And that was a way that you could enter commands on a computer, just let's say ls for list, and you'd get the output. Now that was specific to the computer you were typing it on. Now in this video I'm going to introduce a couple of new concepts. I'm going to introduce a server and a client, and I'm also going to use a program called SSH, which stands for Secure Shell, to demonstrate that. So first of all, the server and client model. Basically, the concept of a server is simply a machine. Let's say this is a server, and it's listening for connections. Okay, that's it. It's not necessarily some big, huge thing in a data center. A server can be tiny, and this one right here, they're both actually servers, so they're both listening for connections. So we'll start with this little one here. It's listening for connections for this secure shell. And what I'm going to do is connect from this machine to that one. So from the big one to the small one. So first of all, let's just jog our memory on the IP addresses. So on the big one here, the address is 192.168.0.10. And on the little one, the address is 192.168.0.11. Okay? I'll get to what the /24 means at a later date, but that's the IP address there. So there are IP addresses. Now let's just say I'm on this computer and that one's remote, because we're playing with networks here. And I'm on here, and you can see that I'm on this local machine because it's called Debian. That's the name of this host, okay? The username is CWNE88, and I'm on this machine here. Over on here, it's the same username, but the machine name's called something different. It's called Small Acer, because it's a small Acer laptop. That's why. So anyway, from here, what I can do is run the command SSH, and I want that IP address. So if I put in 192.168.0.11, I will connect to that. We've done this before, but I'm just going to go through it in depth here. So first of all, we get the authenticity check. Okay, basically what it's doing, because I haven't connected to that before, it gives a fingerprint of itself to say who it is. And if we believe that's who it is, we can just go ahead. And I know that's who it is because we're right here. So type yes, and now it asks for the password. Now this, of course, is the password for the little machine that we're trying to connect to, which is the same as this one anyway, but do that and we're in. Now what you'll notice here is the command prompt, that's this whole thing here, the prompt's changed a bit. Same username, but we're now at the small Acer. So right here I can control that computer. So if I run an IP address now and have a look, you see it shows me 192.168.0.11. That's because all these commands are being run over here, and of course that's its IP address. Okay, so in that situation, this is a client to that server. Now if you remember the OSI model that I went through, there is an application that was listening for that connection. Now that's the SSH server application. When that started, when it was booted up, it listened on a particular port. Now ports are layer 4 in the OSI model, and by listening to connections on port number 22, that program has got control of that port. No one else can listen on port 22 because that application has that port open. Okay, so when I connected from here, I went to that IP address, but I also went to port 22. It's automatic for SSH because that's the default port. Okay, there's like over 65,000 ports, and the ones below 1,024 are what's known as well-known ports for things like this. So anyway, we're connected to it, and we've got a shell. So I'm running things over there now. So list what's in over there. And if I want to make a file, just to prove a point here, I go echo. I made this from the big laptop. Okay, and I'll just output that to a file called test file. Okay, over on the little one here, which is only still logged into itself, if I list what's there, you can see a file there called test file. Okay, there it is. And if I see what's in it, more test file, that's what I just typed. Okay, so that didn't transfer the file over. That just I just created it from there when I was logged into it from here. Okay, and to exit, just exit, and you can see it says it all there. Connection to 192.168.0.11 is closed, and the prompt has come back to here, this Debian machine here. Now that's all good and well, but I used a password to connect to that, and it's not the only way you can connect. you can generate some keys and just use them instead, so you don't have to type a password. So to do that, we just run SSH keygen, okay? And you'll see it's generating a public-private key pair, okay? We'll talk a lot more about that in the future for sure. But basically, it generates two keys, one that you give out to others, that's your public key, and your private key, which is kept here. And they're mathematically tied, okay? But again, we'll go through that further down the track. Anyway, where do you want to save them? Just press enter for the defaults. And to avoid using a password, we can just not put a passphrase on them, okay? Just leave that without a passphrase, and that's generated the keys. Now, to have a look at them, if I just do an ls, you see it only shows the directories that we've seen before. But in Linux, remember we had those extra things you can put on ls, and one of them is A, which means all files. And when I do that, you see there's more in there, okay? You see all these files that begin with dot and directories that begin with the dot. Now the dot basically means hidden directories, okay? I mean, they're not really well hidden. They just don't come up in a normal listing. But when you list with all, the -A, you see the hidden ones. And you see there's this directory called .ssh now. If I go into that, cd.ssh, change directory, list, there's a couple of files. And again, I always do the long H. So basically a long listing and human readable, just force a habit. Okay, so what we've got here now, we've got 3 files in this .ssh directory. So things that are associated with the SSH program. So what have we got here? We've got this, I'll start at the bottom, the known hosts. And you can just look at it with more, okay, because it's just text file. More known hosts. See that there? That represents the host over here. That's its key. So if I go to connect to it, it'll present that, that fingerprint there. This will know about it. It'll say, yeah, I've seen you before. That's cool. Let's go. Because if someone else put a machine here on the same IP address, it would have a different fingerprint, and then that would alarm out. It wouldn't let you do that. Okay? I mean, you could override it, but basically it's to alert you that you may or may not be connecting to the machine you think you are. So that's kept in the known hosts. The other two is the ID RSA and the ID RSA.pub. So if you look at the ID RSA one, you've got this here, and you see at the top, private key. And that's what it looks like. A whole lot of stuff, which you're never going to guess, basically. And the other one, id.rsa.pub. It's a lot shorter. But those two are mathematically tied, as I said. So what we do, or what we can do now to avoid using passwords when we log into the other host, is we can put our public key on the foreign host here that you want to connect to. Okay? So there's an easy way and a hard way. I've talked about both of these before. Well, I've talked about the hard way in a previous video. You might want to check that out. But the easy way is SSH copy ID. Okay? And over to that machine over there, which is 192.168.0.11. And it'll ask me the password to put them in, which is CWNE88. And there it is. It's put those keys in over there. So this time, when I SSH that machine, 0.11, it'll just log straight in without using a password. Okay, so that's handy. And if we have a look on the small machine, which I could have done from there because I was logged into it, but we'll go over here just to keep it clear. Again, list, and you can't really see it, but we know there's a .ssh directory there. If we go in there, we see we have one file called authorized keys. And what does that say? It says that key is authorized. Now, if we go back over here, okay, idrsa.pub, you'll see that those two are the same. So what that did before, that SSH copy ID, was put my public key over to the foreign machine that I'm going to connect to. Okay, you never give out your private key, that stays on here. But once you put the public key on there, we can use that without the password. Now that's good and well, but let's say we think the key's on there, but let's say it gets removed. So over here, I remove that key. And now over here, I try to connect to it. Same as I did before, I SSH to it, and it asked me for the password when I thought the key was on there. Now let's pretend I don't have access to that nice and handy like here. And I want to see what's going on. So I'll just Control-C, get out of that. Now what you can do with most programs pretty much is use, when you run the program, you can put a -v, which means verbose. And that means gives you lots more details on the screen than you normally would have got, okay? And most programs use -v for some extra logging. And when you're doing any fault finding, it's always handy to look at what logs are there. So, like for now, I thought I had my keys on there, but it asked me for a password, so I want to see some extra details. So I'll do that again with the -v, and you'll see what's going on. Now, straight away, you can see a whole lot of stuff came up, okay? Now, if I go back to the top of where that started, we're going to just go through a bit of it. Okay, so we get some logging. We get our version number of SSH, what we're running here, SSL, which is the encryption part of it, bit of that, where it's reading the config from. Now, in Linux, the etc directory pretty much contains your config globally for most things, unless you've got something that overrides it locally, but etc is full of config, basically. Yep. We obviously apply to line 19 of it. We're connecting to that on port 22. As I said, port 22 in layer 4 is the TCP port number that was opened by the SSH server program when it was started. Okay, so we're connecting to that. And we got connected to it. So that's good and well. The next thing it did was check all the identities for it. And then we found out who it is. Okay, now we get the protocol version, SSH version 2. Remote software, what it's running over there, which will be the same as here. Like here we saw we're running this version. It's the same as the remote version, probably because I installed them at the same time with the same system, so the same version. Okay, bit of this, we're on. Now here, we're authenticating to it as CWNE88. Now I could have changed that name to log in as someone else, but I didn't. I just went with just the IP address, which just uses the name you log in here as. So I logged in as CWNE88, or attempting to at the moment. Right, so we initialize the connection here using that's our encryption algorithm here. Algorithm, blah, blah, blah. Okay, we're getting there, no compression. Okay, so all this encryption and compression, remember in the OSI model, that's layer 6 in effect here. Okay, the encryption and compression or not. So it's all in here as part of the application. So, you know, there's a very grey line between those two. Service host key, that's what got presented to us before when we asked if we were really sure that was who it said it was. And so on, blah, 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 same again. Telling it when to do the rekey for it. So these are the keys that it thinks it's going to try, okay? Now, they don't exist on the little laptop, so that's not going to work. But it's going to try them anyway, because it doesn't know that yet. So this is a key line here. Authentications that can continue, we could use public key or password. And it's going to prefer public key, which is what we would have had set up, what I did briefly. So it tried public key. Next authentication method, public key. It offered our key, the one that's in there, the one I showed you, but once it gets over there, it tries it, and this would have rejected it because it doesn't have it. So now the next authentication method is password, and that's when it asks me for password, which is probably timed out by now. Yeah, that's timed out because I took too long, but if I just do it again, CW88, and we're in. You can see that it authenticated, we got our session open, interactive mode, pledge, that's kind of like permissions if you like on phone apps, and that's saying it should only be using the network and nothing fancy like root. And what else? Pretty much setting up our environment, and we're in. From here on, this is what you get when you log in anyway. And it's saying the last login was, I don't know, 10 minutes ago, whenever I did this before. Okay, and we're in. Okay, so that shows a bit of the OSI model in action too. So we had, layer 1 and 2 are there because we're connected. We've got link lights and we're all good there. Layer 3 was the IP address, so I went to the IP address of this machine. Layer 4 would be the port number, the TCP port 22, so that was there. And then we moved up to all the things like we had the encryptions running, and we had the session started, so that's getting up the layers now. And finally at the top we have our SSH session running. So that's a bit of the OSI model, and that's also what a client and server is. So as I said, from there we can do all sorts of things. We can remove that test file, blah, blah, blah. Look what's in here. Look at all this stuff that I've been doing. Look at this. Okay, that's all on the little laptop. If I exit, come back here, CD home, video directory here, totally different. Okay, different stuff. Now there is another program called SCP, which is Secure Copy. You may recall the command to copy a file is CP for copy. Well, SCP is Secure Copy. They've got shell, SSH is Secure Shell, SCP is Secure Copy. And it lets you copy files from one host to another. And of course it's secure, as the name implies, and it uses the same protocol as SSH. So it actually uses the same server. So the SSH server on here is the same whether I'm using SSH or SCP. Okay, so therefore it's still TCP port 22. Okay, so I'll leave that there and have fun connecting to other machines, and don't do anything dodgy, because I have never done anything dodgy ever in my life. Till next time, take it easy.